Okay, so now that I'm caught up on my homework a little bit about how epinephrine and norepinephrine cause all the good effects, let's talk about vasodilation and vasoconstriction. Now, vasodilation is when your blood vessels get bigger, and if they get bigger, you decrease your blood pressure because your blood flow, your blood vessels get bigger, so you decrease the pressure. When you vasoconstrict, by now this should be a simple review. You increase your blood pressure because your vessels get smaller. Now the most important thing during exercise, all your body really cares about is regulating blood pressure. It wants to regulate blood pressure because if you let blood pressure get out of hand, you're going to die or not good. So you want to regulate blood pressure. So epinephrine and catecholamines have a big role to regulate your blood pressure. Now the important thing to know is when you cause vasodilation and when do you cause vasoconstriction. First, and specifically the question is why in rest do you cause vasodilation and why in exercise do you cause vasoconstriction. Now, going back to the receptors, we have beta receptors and we have alpha receptors. Now, beta receptors are mainly cause vasodilation, just call it that way. Alpha cause vasoconstriction. Receptors do different things. We really don't care about norepinephrine, we're just talking about epinephrine. Now if rest we're mainly doing vasodilation. And at exercise we're mainly doing vasoconstriction. Vasoconstriction. Why? Why do we mainly do this? The reason being because at rest, epinephrine is mainly binding to beta receptors, and at exercise, epinephrine is mainly binding to alpha receptors. Now, the reason for this is because you release, of course, a lot of it. Now, remember the percentage of 80% epinephrine, 20% norepinephrine? That's mainly when you're exercising, you release a shit ton of epinephrine and adrenaline. Now, when you're at rest, you really don't release a lot of epinephrine because you really don't have a lot of adrenaline when you're resting. Right? It's common, everyone knows this, when you're resting, your heart rate's usually not elevated, you don't have all this adrenaline in your system. It's when you start exercising, and 75% of your heart rate. So, at rest, you only have a few, say you only have okay, that's a very unrealistic number, but say you have 200 adrenaline molecules, or epinephrine molecules. You don't have a lot of epinephrine, but you have a lot more norepinephrine. Yet, epinephrine has a very high affinity for the beta receptors, so it's more likely going to bind to the beta receptors, or even though there's a lot more alpha receptors than beta receptors in the body, the epinephrine is going to bind to the beta receptor because it has a higher affinity for it. Now when you start exercising, now you have like 2,000 adrenalines in your body when you exercise, just picking random numbers. Now, even though it has a high affinity for the beta receptors, you have so many alpha receptors that it's going to bind to the alpha before it binds to the beta. So you're going to cause mostly vasoconstriction at rest, and exercise, and vasodilation and rest because of the affinity of the receptors and the amount of receptors. You have a lot of alpha receptors and a few beta receptors, but epinephrine loves beta receptors. So it's more likely to bind to beta receptors when there's a little bit of epinephrine. But when there's a lot of epinephrine, like exercise, it's going to bind to the alpha receptors. Okay, we'll skip that and stop talking about these confusing things. And now, we kind of already went over question 7, or essentially, how do the catecholamines regulate blood glucose? Like, how do they cause it? Remember, we talked about the whole bank account with glycogen and glycogenolysis and all that good stuff. So, talk about epinephrine, since that's the one we care about. Epinephrine raises your blood glucose because it causes mainly glycogenolysis. It causes you to withdraw energy or glucose from your money reservoir of glycogen in your body. You have all this glycogen, spelled that wrong I think, but you have all this glycogen, it's stored glucose, and your body releases adrenaline, it has to get that glucose, so it breaks down glycogen or goes through glycogenolysis so you get that glucose. Just like you want to buy something fancy, you have all this money in your bank account, you need to take the money, you need to withdraw the money from your bank account to get the money. You have to withdraw the glucose from the glycogen in order to get energy. Now, Epinephrine isn't specific to just glycogen. It does anything it can to increase. Epinephrine's main thing is to increase your blood glucose. And it's really a lot of these hormones in the body. It just wants to increase your blood glucose. There's other ways besides breaking down glycogen to increase your blood glucose. There's also gluconeogenesis. Epinephrine doesn't really do that, but remember that fats are a massive source for energy. They can produce a shit ton of ATP. So epinephrine, adrenaline burns a lot of fat because fats is a huge source of energy. It's a huge reservoir of energy. This kind of relates back to high-intensity interval training, actually. High-intensity interval training is very intense, so you release a lot of adrenaline when you work out at a high intensity. Since you release a lot of adrenaline, you burn a lot of fat. So when you're jogging, you're not really releasing adrenaline because you're not working out hard enough. So if you're not releasing adrenaline, you're not really burning a lot of fat. You're not really doing that. So that's another reason why high-intensity training is good for you. Because you release a lot of epinephrine. With a lot of epinephrine, you do lipolysis a lot. Now, I'll just mention norepinephrine just for the hell of it. Norepinephrine is a neurotransmitter. It's mainly neurotransmitter. It's not really released from as a hormone. Now, epinephrine is actually a precursor for norepinephrine is actually a precursor for epinephrine, which means if you have a lot of norepinephrine in your body, you can actually form epinephrine from it. It's pretty cool. But still, norepinephrine is a neurotransmitter. But you could form epinephrine from norepinephrine if you have a lot of norepinephrine. So, what else can we talk about? Norepinephrine increases your heart rate, blah, 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 causes vasoconstriction, we know this. Okay. Now we'll talk about glucagon, which we're going to talk about glucagon probably a lot. Alright, so let's talk about insulin and glucagon. Insulin is released from the pancreas, just like glucagon. We'll talk about the specific cell it's released from. You have your pancreas. Say you have a lot, you just ate blood sugar, you just ate sugar, or you eat anything in the body. Everything has sugar. So you have all this sugar in your blood system. Now, in your system. Now you have to get the sugar into your cells, like we talked about before, millions of times in the first test. Yeah, actually, I didn't make videos for the first test, but forget that. But you have to get the sugar into your cells. In order to get the sugar into your cells, you have insulin, because you have the cell, you have all this blood sugar circulating the cell. It can't get into the cell. Insulin lets it into the cell. Insulin is like the key. Okay, so insulin lowers your blood sugar because it causes glucose to go into the cell. The physiology word for it is it causes glycolysis, so you break down glucose. It causes glycogenesis, so you build up glycogen. So it's just like depositing money in your bank account. So let's relate this all to money, because money is awesome. Glycolysis would be like spending money. You're spending your glucose for energy, or you're spending your money. Glycogenesis is like using the glucose to form glycogen, or you putting your money in a bank account. So it's kind of the same thing. Now, insulin is a major anabolic hormone, meaning it builds everything in the body. It also builds protein. But the really important thing about it is it builds fat. So it deposits fat in adipose tissues, which that essentially means it forms fat. It's a fat synthesizer in the body, which is why when we get talk about diabetes, most diabetics or type 2 diabetics are overweight or obese because they release a lot of insulin, and insulin greatly increases fat storage. That's just a little side effect that we'll get to. But let's talk about, didn't really say where it's released from. It's released from the pancreas. It's released from a specific cell in the pancreas. It's released from the beta cells in the islets of Langerhans. I'll just write that out. Islets of Langerhans. Probably some dude named Langerhans discovered it, so they named it after him. So discover something in the body, get it named after you. So islets of Langerhans. Now, done with that. Glucagon is kind of like the antagonist of hormone. It's a hormone. Let's say it's insulin's enemy. It's an enemy of insulin. why insulin is low in your blood sugar, causing glycolysis. You're spending all this money, or you're spending this glucose, or you're putting the glucose into the bank account to form glycogenesis. Glucagon increases your blood sugar. Increases blood sugar. So say you just ate, you release insulin so you can lower your blood sugar. Now your blood sugar gets so low that you release glucagon to raise your blood sugar. This actually happens on an everyday basis. If you don't eat for, say, 4 hours and you get hungry, that's because the blood sugar is low and it's actually signaling to your, well, first your stomach that you're hungry, and then your stomach signals your brain, and your brain sends a signal to release glucagon. And glucagon will increase your blood sugar. How does it do this? Kind of the same way that epinephrine increases your blood sugar. It causes glycogenolysis, so you break down glycogen, or you withdraw from that bank account of glycogen, but it also causes gluconeogenesis, which is the formation of glucose from non-glucose molecules, mainly from fat. So let's put in parentheses, fat and not really proteins, but fat and proteins can form glucose by gluconeogenesis. And this is how glucagon works. Glucagon is mainly to raise the blood sugar in the body. And it will do this from these two ways, from glycogenolysis, breaking down your glycogen, so the sugar can re-enter the bloodstream and you can be satisfied, or it will increase gluconeogenesis. Now, this is released from the alpha cells in the islets of Langerhans. Remember, insulin, beta, alpha, glucagon. Let's try to think of a good way to remember that. I can't think of anything. Just remember it. Okay, now what's the main importance? We talked about insulin, of course, glucagon, but we'll forget insulin. Insulin's an exception, lowers blood sugar. Insulin and epinephrine. Now these both, from this point, all the hormones we're going to talk about are going to raise blood sugar. These both raise blood sugar. What is the difference? They both raise blood sugar. They both cause an increase of glycogenolysis, which will in turn raise blood sugar. Of course, this causes gluconeogenesis, and this doesn't, but they want to raise blood sugar. What is the difference? You should probably know this by now. This is mainly released during exercise. It's adrenaline. This is mainly released at rest. When you're exercising, you really don't release too much glycogen, and when you release epinephrine at rest, but you release epinephrine mostly when you're exercising. So that's mainly the things we care about.